Hi, today we're looking at 9.1, verifying trigonometric identities and simplifying expressions. So the important identities that you want to have memorized are sine squared plus cosine squared is equal to 1. The second one comes from dividing everything by sine squared. If you divide everything by sine squared, you will get 1 plus cotangent squared is equal to secant squared. And if you divide everything by cosine squared, you will get tangent squared plus 1 is equal to cosecant squared. The next identities are the even odd functions. So even functions are symmetric about the y-axis, and those would be cosine and secant. And the odd functions are always symmetric about the origin, and those functions would be sine, tangent, cosecant, and cotangent. Great. Let's move on to the next page. If you go back to page 1, there's a variation of this identity. If you subtract cosine squared to both sides, you get the identity sine squared theta is equal to 1 minus cosine squared theta. You can also subtract sine squared theta to both sides, and that will give you cosine squared theta equals 1 minus sine squared theta. So these two become identities that can also be used, and they come up quite often as a matter of fact. So these are two more identities that you actually want to have memorized because they come up so often in these problems. So that's exactly what we have. We have 1 minus cosine squared, which is equal to sine squared. So if you go, so the other things that you really need to have memorized are the reciprocal identities, which are sine is equal to 1 over cosecant, cosine is equal to 1 over secant, tangent is equal to 1 over cotangent, and for whatever reason they didn't state these, but these also apply. Cosecant is equal to 1 over sine theta, and secant is equal to 1 over cosine theta. So those are identities that you really need to have memorized. And then the quotient identities are tangent is equal to sine theta over cosine theta, and cotangent is equal to cosine theta divided by sine theta. So those are going to be very helpful to have memorized. So when you're verifying identities, you can work on these problems and not really run into hiccups. All right, to verify an identity, you usually want to start with the more complicated side. So complicated side of the equation. Okay, because you're going to have an equation and you're going to have two sides of the equation, and you want to, the goal is to make the left side look like the right side. All right, so you always want to start on the side that's more complicated and simplify it. You want to look for opportunities to simplify expressions. So let's write that, simplify. Square a binomial, or factor trinomials, or add fractions. There's different things that you can do to simplify expressions that you will see will come up. And you definitely want to substitute fundamental identities such as the Pythagorean identities, the reciprocal identities, the ones that we just went over. If you get stuck, it's recommended that you convert all terms to sine and cosine. Usually that will help. So let's take a look at our first identity. As you can see, we have tan theta times cosine theta equals sine. And as you can see, the left side is clearly more complicated than the right side. So let's start on the left side. The way you can start this is by rewriting tangent as sine theta over cosine theta. All right, that's a good start. And then you want to multiply that by cosine theta. And hopefully that will equal sine theta, which you will see it will. And now you can see that there is cancellation here. Cosines cancel. And so now we're left with sine theta equals sine theta. And we're done. So that's a goal. The goal is to make one side equal to the other side by simplifying. So we're good there. Let's move on to the next problem. So as you can see, the left side in this problem is the more complicated side. So we're going to simplify the left side by rewriting terms in terms of sine and cosine. So cosecant can be written as 1 over sine. That's by definition. Cosine, you just leave that alone. Tangent can be written as sine theta over cosine theta by definition. And we want to see if that is actually going to equal 1. Well, as you can see, the sines cancel because you have 1 in the numerator and 1 in the denominator, and the cosines also cancel for the same reason. So you end up with 1 equal to 1, which is the end of the verification. So that's how these go. You're just trying to make one side equal to the other side. Let's move on to the next page. Mention that back to our problem. Okay. Oftentimes you will have to use algebra techniques in order to simplify. So when you have the difference of two squares, that can be rewritten as a minus b times a plus b, right? So for example, let's give you an algebraic example. Let's say you had x squared minus 9. Well, that would factor into, that's the difference of two squares because x squared is a perfect square and 9 is a perfect square. So that would become x plus 3 times x minus 3. Sometimes you'll have situations where you have trig functions, such as sine squared minus 1. That is also the difference of two squares. That can be written as sine theta plus 1 sine theta minus 1. So those are just, that's a technique that will be used in certain problems. Not all problems, certain ones. So let's look at this next problem, exercise number 3. As you can see, you have secant squared minus 1 over secant squared. In this case, you could factor the numerator into the difference of squares like we did this problem over here, but it actually is easier if you just simplify by separating the terms. So you can separate the fraction into two separate fractions. You do the first term divided by the denominator minus the second term divided by the denominator. That's an algebraic technique that you're also allowed to do. You separate the fraction into two separate fractions, and then you'll see that secant squared divided by secant squared is 1 minus, and if you recall, the definition of 1 over secant is cosine. It's a reciprocal function, so therefore 1 over secant squared must be cosine squared. All right, and on the right side, we leave that alone, leave it as is. And going back to the identities, I forgot to, we'll see that 1 minus cosine squared is in fact equal to sine squared, which is exactly what is on the right side. So we're done. Okay. Okay, moving on. All right, this problem is asking us to rewrite the trigonometric expression for cosine squared minus 1 using the difference of squares. So as you can see, they're actually telling you what to do. They're telling you to use the difference of squares. Okay, so let's break this up. Well, if you break up 4 cosine squared, that's 2 cosine theta times 2 cosine theta. And if you break up negative 1, that's positive 1 times negative 1. So therefore, the factors become 2 cosine theta plus 1, 2 cosine theta minus 1. And that is the final answer. Okay, let's move on down to this one. Notice that this one can also be factored into the difference of two squares because you have a perfect square minus a perfect square. So you could actually do the same thing if you wanted to, but they're not asking us to do that. They're asking us to simplify. And there turns out to be a better way to do this one. So cosecant, by definition, is equal to 1 over sine theta, but because it's squared, this is also squared. And cotangent, by definition, is cosine theta over sine theta, and similarly, that's squared, therefore these are squared. And the reason I'm going this route is because now we have a common denominator. So that's why I decided that it would be best to go this route, because I knew that there would be a common denominator, because this is 1 over sine squared and this is cosine squared over sine squared. That's the reason why it's important to have these reciprocal identities memorized, because then you can foresee what step is in your best interest to take, basically. All right, so now that we have a common denominator, we can go ahead and add these two fractions together. The denominator will be sine squared. And if you write out the numerator, you'll have 1 over cosine squared theta, which again is equal to that identity, sine squared. So that's, again, why it's important to have those memorized, because automatically, as soon as you see 1 minus cosine squared, you should always think sine squared. All right, sine squared over sine squared is 1. And that is our final answer. So as you can see, this expression is equal to 1. Okay, moving on to the next page. Okay, so now we have two terms, as you can see. 1, 2. What I recommend in this situation, when you have two terms such as this one, is to rewrite this in terms of sines and cosines. So let's start with that one. So this stays the same. Cosine theta over 1 plus sine theta plus tangent, which is by definition is sine theta over cosine theta. Put this in parentheses because we're going to have to add these two fractions together. So when you're adding two fractions together, you do need a common denominator. And the common denominator is going to be this times this. That's how you find common denominators. Usually when you're doing trig functions, you just multiply the factors. So that's one factor times the other factor. That's your common denominator. So now we need to add the two fractions. So in this case, we're missing the factor cosine theta. So you have to multiply top and bottom of the fraction by the missing factor in order to make the common denominator the same. And for the other one, you want to multiply the other one by 1 plus sine theta. 1 plus sine theta. And now if we simplify the numerators, you will get cosine squared. That comes from cosine times cosine. Over here, we have to distribute the sine. So distribute the sine, and you will get plus sine theta plus sine squared theta. And now, if you look at this expression, look at the numerator, you should recognize that cosine squared plus sine squared is equal to 1. So that's once again why it's important to know the identities like the back of your hand, because those two terms add up to 1. Cosine squared plus sine squared is equal to 1. So now we can rewrite the numerator as 1 plus sine theta over 1 plus sine theta in parentheses times cosine. And now we have a common factor that can be canceled out. And so we're left with 1 over cosine theta, which by definition is equal to secant theta. So once again, this section is all about recognizing identities, whether it's Pythagorean identities, reciprocal identities, quotient identities. You just want to know those really well so that these problems can become much easier for you to solve. All right, the last one, as you can see, this one looks a little bit more complicated, but this time, since there is a sine plus 1 here, and this is a difference of 2 squares, I am going to factor this into the difference of 2 squares. So hopefully you recognize that sine squared can be written as sine plus 1, sine minus 1, sine theta plus 1, sine theta minus 1. So what I did was I factored the difference of 2 squares. Sine squared minus 1 becomes sine times sine. Negative 1 becomes positive 1 times negative 1. Now let's look at the denominator. Notice there's a common factor, tangent theta, tangent theta. Therefore, we can factor out the common factor. Whoops. So if we factor out the common factor, we will be left with tan theta, parentheses, sine theta minus 1. All right, I simply factored out the tan here, so I'm left with sine minus 1. And look at that, we can cancel out the sine minus 1s. And we are done at that point, because on the right side, we're left with sine theta plus 1 over tangent theta, which is exactly what we have on the left side. And we are done.